In this video, we will be going through concrete masonry unit code requirements, reinforcement specifications, wall types, submittals approval. We'll review typical CMU drawings along with actual job site pictures, masonry sampling inspection. Stay tuned. If you are interested in building codes and standards and want to get ICC certification, visit the Building Code Academy and get study material to pass your building inspector exam. Building Code Academy also includes educational material in concrete reinforcement, welding, bolting, video tutorial in electrical, plumbing, heating, ventilation, air conditioning, and much more. Subscribe to our YouTube channel and remember to turn on the notification bell. Before starting masonry work, building official approval is required for the following submittals: CMU shop drawings, product data, hot and cold weather procedures, cementitious materials, insulation, anchors, ties, mock-up panel, joint reinforcement, veneer anchor calculations. Mock-up panel location. Show full color range, texture, and bond pattern of the masonry work. Demonstrate mortar joint tooling, grouting of reinforced vertical cores, collar joints, bond beams, and lintels, positioning, securing, and lapping of reinforcing steel, positioning and lapping of joint reinforcement, including prefabricated corners, and cleaning of masonry work during the construction of the panels. Also include installation or application procedures for anchors, wall ties, CMU control joints, insulation, and flashing. Include a masonry bonded corner and a bond beam corner. When the panel represents reinforced masonry, include a 2 by 2 foot opening placed at least 2 feet above the panel base and 2 feet away from all free edges, corners, and control joints. Provide required reinforcing around this opening as well as at wall corners and control joints. Mock-up panel purpose. The completed panels are used as the standard of workmanship for the type of masonry represented. Do not commence masonry work until the mock-up panel for that type of masonry construction has been completed and approved. Protect panels from the weather and construction operations until the masonry work has been completed and approved. Perform cleaning procedures on the mock-up and obtain approval of the building official or contracting officer prior to cleaning the building. After completion of the work, completely remove the mock-up panels, including all foundation concrete, from the construction site. Do not build in mock-up panels as part of the structure. Locate mock-up panels where directed. Construct portable mock-up panels or locate in an area where they will not be disrupted during construction. Special Masonry Inspector Qualifications Requirements. Inspector must have ICC Structural Masonry Special Inspector Certificate with 1 year of related experience, or Registered Professional Engineer with 3 years of related experience. Make a copy of the Special Inspections Project Manual available on the job site during construction. Submit a copy of the Special Inspections Project Manual for approval. Maintain a 3-ring binder for the Special Inspector's daily and bi-weekly reports and the Special Inspections Project Manual. This file must be located in a conspicuous place in the project trailer or office to allow review by the building official or contracting officer. Discrepancies that are observed during special inspections must be reported to the QC manager for correction. If discrepancies are not corrected before the special inspector leaves the site, the observed discrepancies must be documented in the daily report. Perform special inspections in accordance with Chapter 17 of ICC International Building Code. Special inspections are to be performed by an independent third party and are intended to ensure that the work of the prime contractor is in accordance with the contract documents and applicable building codes. Masonry inspector to verify the following are in compliance at start of construction. Compliance with approved submittals prior to start. Observe preparation of grout specimens, mortar specimens, and prisms by collecting samples and sending them to the lab for compressive strength test. Inspector to verify grade and type of reinforcement, anchor bolts, and pre-stressing tendons and anchorages. Size and location of structural elements is in compliance. Also preparation, construction, and protection of masonry during cold weather when the temperature below 40 Fahrenheit or hot weather above 90. Deliver, store, handle, and protect material to avoid chipping, breakage, and contact with soil or contaminating material. Store and prepare materials in already disturbed areas to minimize project site disturbance and size of project site. Store steel reinforcing bars, coated anchors, ties, and joint reinforcement above the ground. Maintain steel reinforcing bars and uncoated ties free of loose mill scale and loose rust. Deliver cementitious and other packaged materials in unopened containers, plainly marked and labeled with manufacturers' names and brands. Store cementitious material in dry, weathertight enclosures or completely cover. Handle cementitious materials in a manner that will prevent the inclusion of foreign materials and damage by water or dampness. Store sand and aggregates in a manner to prevent contamination and segregation. Product system description. Design specified compressive strength of masonry. The specified compressive strength of masonry, FM, is indicated in structural general notes for each building to be constructed with masonry. Verify specified compressive strength of masonry using the PRISM test method by certified special inspector and laboratory break results. PRISM tests. Perform at least one PRISM test sample for each 5,000 square feet of wall but not less than 3 such tests for any building, typical. Evaluate 3 prisms in each test. Fabricate, store, handle, and test prisms in accordance with ASTM C1314. 7-day tests may be used provided the relationship between the 7 and 28-day strengths of the masonry is established by the tests of the materials used. If the compressive strength of any prism falls below the specified value by more than 500 psi, take steps to assure that the load-carrying capacity of the structure is not jeopardized. If the likelihood of low-strength masonry is confirmed and computations indicate that the load-carrying capacity may have been significantly reduced, tests of cores drilled, or prisms sawed, from the area in question may be required. In such case, take 3 specimens for each prism test more than 500 psi below the specified value. Masonry in the area in question will be considered structurally adequate if the average compressive strength of 3 specimens is equal to or exceeds the specified value. Additional testing of specimens extracted from locations represented by erratic core or prism strength test results will be permitted. General requirements. Do not change the source of materials, which will affect the appearance of the finished work, after the work has started except with building official approval. Submit test reports from an approved independent laboratory. Certify test reports on a previously tested material as the same materials as that proposed for use in this project. Submit certificates of compliance stating that the materials meet the specified requirements. CMU units that are located on exposed surfaces must be smooth and of uniform texture. Concrete masonry units must be added with water repellent admixture during manufacture where units will be exposed to weather. Unit types. Hollow load-bearing units shall conform to ASTM C90 and can be lightweight, normal weight, and heavyweight. Load-bearing units for exterior walls, foundation walls, load-bearing and shear walls. Non-load-bearing units for interior partition walls not exposed to the weather. Load-bearing units may be provided in lieu of non-load-bearing units. Solid load-bearing units, ASTM C90, normal weight units. Solid units shall be provided as indicated in drawings. CMU unit typical dimension of 8, 10 and 12 inches wide, 8 inches high, and 16 inches long. Precast concrete units. Provide precast concrete trim, lintels, copings, splash blocks and sills that are factory-made units in a plant regularly engaged in producing precast concrete units. Unless otherwise indicated, provide precast concrete with minimum 4,000 psi, compressive strength, using 1/2 inch to 4 nominal size coarse aggregate, and with reinforcement required for handling of the units. Maintain minimum clearance of 3/4 inch between reinforcement and faces of units. Mortar materials. Use mortar pigment that conforms to ASTM C979 or C979M. Add pigment to mortar to produce a uniform color matching adjacent masonry. Furnish pigments in accurately pre-measured and packaged units that can be added to a measured amount of cementitious materials or supply pigments via pre-blended cementitious materials or dry mortar mix. Admixtures for masonry mortar. In cold weather, use a non-chloride-based accelerating admixture that conforms to mortar. ASTM C1384, unless Type 3 Portland cement is used in the in-showers and kitchens, use mortar that contains a water-repellent admixture, conforming to ASTM C1384. Provide a water-repellent ASTM C1384 and of the same brand and manufacturer as the block's integral water repellent, in the mortar used to place concrete masonry units that have an integral water-repellent admixture. Mortar mix. Provide mortar type S, N, O, or M, as specified otherwise herein. Do not use masonry cement in the mortar. Do not use air entrainment in the mortar. Use ASTM C270 Type S cement lime mortar for seismic force resisting elements indicated. Type M mortar mix has the highest amount of Portland cement and is recommended for heavy loads. Type M mortar provides at least 2,500 psi, Type S 1,800 psi, Type N 750 and Type O 350 psi, at 28 days. For field batched mortar, measure component materials by volume. Use measuring boxes for materials that do not come in packages, such as sand, for consistent batching. Mix cementitious materials and aggregates between 3 and 5 minutes in a mechanical batch mixer with a sufficient amount of water to produce a workable consistency. Do not hand mix mortar unless approved by the contracting officer or building official. Maintain workability of mortar by remixing or retempering. Discard mortar that has begun to stiffen or is not used within 2.5 hours after initial mixing. Ready mix grout. Use conventional grout with a slump between 8 and 11 inches. Use self-consolidating grout with slump flow of 24 to 30 inches. Provide minimum grout strength of 2,000 psi, in 28 days, as tested in accordance with ASTM C1019. Do not change proportions and do not use materials with different physical or chemical characteristics in grout for the work unless additional evidence is furnished that grout meets the specified requirements. Use ready-mixed grout that conforms to ASTM C476. Pumping grout through aluminum tubes is not permitted. Placing grout. Grout all walls solid full height or as shown on construction drawings. Discard site mixed grout that is not placed within 1.5 hours after water is first added to the batch or when the specified slump is not met without adding water after initial mixing. Discard ready-mixed grout that does not meet the specified slump without adding water other than water that was added at the time of initial discharge. Allow sufficient time between grout lifts to preclude displacement or cracking of face shells of masonry units. Provide a grout shear key between lifts when grouting is delayed and the lower lift loses plasticity. If blowouts, flowouts, misalignment, or cracking of face shells should occur during construction, tear down the wall and rebuild. Cleanouts for hollow unit masonry construction. Provide cleanout holes at the bottom of every grout pour in cores containing vertical reinforcement when the height of the grout pour exceeds 5 feet 4 inches. Where all cells are to be grouted, construct cleanout courses using bond beam units in an inverted position to permit cleaning of all cells. Provide cleanout holes at a maximum spacing of 32 inches where all cells are to be filled with grout. Establish a new series of cleanouts if grouting operations are stopped for more than 4 hours. Provide cleanouts not less than 3 by 3 inch by cutting openings in one face shell. Manufacturer's standard cutout units may be used at the contractor's option. Do not clean out holes until masonry work, reinforcement, and final cleaning of the grout spaces have been completed and inspected. For walls which will be exposed to view, close cleanout holes in an approved manner to match surrounding masonry. Grout placement. A grout pour is the total height of masonry to be grouted prior to erection of additional masonry. A grout lift is an increment of grout placement within a grout pour. A grout pour is filled by one or more lifts of grout. If the masonry is cured at least 4 hours, grout slump is maintained between 10 to 11 inches, and no intermediate reinforced bond beams are placed between the top and bottom of the pour height. Place conventional grout in lifts not exceeding 12 feet 8 inches. For the same curing and slump conditions but with intermediate bond beams, limit conventional grout lift to the bottom of the lowest bond beam that is more than 5 feet 4 inches above the bottom of the lift, but do not exceed 12 feet 8 inches. If masonry has not cured at least 4 hours or grout slump is not maintained between 10 to 11 inches, place conventional grout in lifts not exceeding 5 feet 4 inches. Consolidate conventional grout lift and reconsolidate after initial settlement. For grout pours that are 12 inches or less in height, consolidate and reconsolidate grout by mechanical vibration or puddling. For grout pours that are greater than 12 inches in height, consolidate and reconsolidate grout by mechanical vibration. Apply vibrators at uniformly spaced points not further apart than the visible effectiveness of the machine. Limit duration of vibration to time necessary to produce satisfactory consolidation without causing segregation. If previous lift is not permitted to set, dip vibrator into previous lift. Do not insert vibrators into lower lifts that are in a semi-solidified state. If lower lift sets prior to placement of subsequent lift, form a grout key by terminating grout a minimum of 1.5 inch below a mortar joint. Vibrate each vertical cell containing reinforcement in partially grouted masonry. Do not form grout keys within beams. Veneer anchors, ties, and bar positioners. Wall ties for multi-withe masonry construction provide rectangular-shaped wall ties, fabricated of hot-dipped galvanized W2.8 diameter steel wire to connect veneer to light-gauge steel or concrete or masonry backing. Provide hot-dip galvanized adjustable anchors for connecting masonry walls to the structural steel frame as detailed on the drawings. Ties must comply with seismic requirements. Provide adjustable type wall ties that consist of 2 essentially U-shaped elements that are inserted to eyes of horizontal joint reinforcement, hot-dip galvanized. Form the pintle and eye elements shall be formed so that both can be in the same plane. Bar positioners. Factory fabricate bar positioners, used to prevent displacement of reinforcing bars during the course of construction, from 9-gauge steel wire or equivalent, and hot-dip galvanized. Bar positioners must be suitable for intended use and be corrosion-resistant steel. Bar positioners not fully contained within the width must be hot-dip galvanized. Joint reinforcement. Factory fabricate joint reinforcement in conformance with ASTM A951. Provide ladder-type joint reinforcement, having 1 longitudinal wire in the mortar bed of each face shell for hollow units and 1 wire for solid units, and with all wires a minimum of 9 gauge. Size joint reinforcement to provide a minimum of 5/8 inch cover from each face. Space cross wires not more than 16 inches. Provide joint reinforcement for straight runs in flat sections not less than 10 feet long. Provide joint reinforcement with factory-formed corners and intersections. If approved for use, joint reinforcement may be furnished with adjustable wall tie features. Submit one piece of each type used, including corner and wall intersection pieces, showing at least 2 cross wires. Anchored veneer construction. Do not install veneer until the exterior sheathing, moisture barrier, veneer anchors and flashing have been installed on the backing. Take extreme care to avoid damage to the moisture barrier and flashing during construction of the masonry veneer. Repair or replace portions of the moisture barrier and flashing that are damaged prior to completion of the veneer. Provide anchors, ties to connect the veneer to its backing in sufficient quantity to comply with the following. Provide at least one tie every 2 square feet at a maximum spacing of 16 inches in either direction. With solid units, embed anchors or tie in mortar joint and extend into the veneer a minimum of 1.5 inch, with at least 5/8 inch mortar covered to the outside face. Reinforcing steel bars. Reinforcing steel bars and rods shall conform to ASTM A615M, or a 996M, grade 60 typically or as shown in the drawings. Bar reinforcement installation. Submit detail shop drawings showing bar splice locations and reinforcement details compliant with Seismic Design Category D requirements. Identify bent bars on a bending diagram and reference and locate such bars on the drawings. Show wall dimensions, bar clearances, and wall openings. Utilize bending details that conform to the requirements of ACISP 66. No approval will be given to the shop drawings until the contractor certifies that all openings, including those for mechanical and electrical service, are shown. If, during construction, additional masonry openings are required, resubmit the approved shop drawings with the additional openings shown along with the proposed changes. Clearly highlight location of these additional openings. Provide wall elevation drawings with minimum scale of 1/4 inch per foot. Submit drawings including plans, elevations, and details of wall reinforcement, details of reinforcing bars at corners and wall intersections, offsets, tops, bottoms, and ends of walls, control and expansion joints, lintels, and wall openings. Form splices by lapping bars as indicated. Do not cut, bend or eliminate reinforcing bars. Foundation dowel bars may be field bent when permitted by construction officer or building official. Concrete masonry control joint keys. Provide control joint keys of a factory fabricated solid section of natural or synthetic rubber, or combination thereof, conforming to ASTM D2000 with a minimum durometer hardness of 80. Form the control joint key with a solid shear section not less than 5/8 inch thick and 3/8 inch thick flanges, with a tolerance of plus or minus 1/16 inch, to fit neatly, but without forcing, in masonry unit jam sash grooves. Clean reinforcement of loose, flaky rust, scale, grease, mortar, grout, and other coatings that might destroy or reduce its bond prior to placing grout. Do not use bars with kinks or bends not shown on the approved shop drawings. Unless otherwise indicated, extend vertical wall reinforcement to within 2 inches of tops of walls. Through-wall flashing and weeps. Provide reinforced membrane sheet flashing, metal or coated metal flashing. Install through-wall flashing at obstructions in the cavity and where indicated on drawings. Ensure continuity of the flashing at laps and inside and outside corners by splicing in a manner approved by the flashing manufacturer. Ensure that the top edge of the flashing is sealed by applying compatible sealant at the top edge of the through-wall flashing. Provide sealant below the drip edge of through-wall flashing. Weep ventilators. Provide weep ventilators that are prefabricated from stainless steel or plastic. Provide inserts with grill or louver type openings designed to allow the passage of moisture from cavities and to prevent the entrance of insects, and with a rectangular closure strip to prevent mortar droppings from clogging the opening. Provide ventilators with compressible flanges to fit in a standard 3/8 inch wide mortar joint and with height equal to the nominal height of the unit. Weep is typically installed 24 inches on center on the first veneer core. Flashing and weeps. Wherever through-wall flashing occurs, provide weep holes to drain flashing to exterior at acceptable locations as indicated. Locate weeps not more than 24 inches on centers and mortar joints of the exterior with directly on the horizontal leg of through-wall flashing over foundations, bond beams, and any other horizontal interruptions of the cavity. Place weep holes perfectly horizontal or slightly canted downward to encourage water drainage outward and not inward. Other methods may be used for providing weeps when spacing is reduced to 16 inches on center and approved by the building official. Maintain weeps free of mortar and other obstructions. Bracing. Provide bracing and scaffolding necessary for masonry work. Design bracing to resist wind pressure as required by OSHA and local codes and submit bracing calculations. Do not remove bracing in less than 10 days. Coordinate masonry work with the work of other trades to accommodate built-in items and to avoid cutting and patching. Lay masonry units in running or stock bond pattern as indicated in drawings. Lay facing courses level with backup courses, unless the use of adjustable ties has been approved, in which case the tolerances is plus or minus half an inch. Adjust each unit to its final position while mortar is still soft and has plastic consistency. Remove and clean units that have been disturbed after the mortar is stiffened, and relay with fresh mortar. Keep air spaces, cavities, chases, expansion joints, and spaces to be grouted free from mortar and other debris. Select units to be used in exposed masonry surfaces from those having the least amount of chipped edges or other imperfections detracting from the appearance of the finished work. Jointing. Tool mortar joints when the mortar is thumbprint hard. Tool horizontal joints after tooling vertical joints. Brush mortar joints to remove loose and excess mortar. Provide 3/8 inch wide mortar joints in concrete masonry. Cutting and fitting. Use full units of the proper size wherever possible, in lieu of cut units. Locate cut units where they would have the least impact on the architectural aesthetic goals of the facility. Perform cutting and fitting, including that required to accommodate the work of others, by masonry mechanics using power masonry saws. Concrete masonry units may be wet or dry cut. Before being placed in the work, dry wet cut units to the same surface dry appearance as uncut units being laid in the wall. Provide cut edges that are clean, true and sharp. Carefully make openings in the masonry so that wall plates, cover plates or escutcheons required by the installation will completely conceal the openings and will have bottoms parallel with the masonry bed joints. Provide reinforced masonry lintels above openings over 12 inches wide for pipes, ducts, cable trays, and other wall penetrations, unless steel sleeves are used. Do not reduce masonry units in size by more than 1/3 in height and 1/2 in length. Do not locate cut products at ends of walls, corners, and other openings. Masonry lintels. Construct masonry lintels with lintel units filled solid with grout in all courses and reinforced with a minimum of 2 number 4 bars in the bottom course unless otherwise indicated on the drawings. Extend lintel reinforcement beyond each side of masonry opening 40 bar diameters or 24 inches, whichever is greater. Support reinforcing bars in place prior to grouting and locate 1/2 inch above the bottom inside surface of the lintel unit. Precast concrete and steel lintels. Provide precast concrete and steel lintels as shown on the drawings. Set lintels in a full bed of mortar with faces plumb and true. Provide steel and precast lintels with a minimum bearing length of 8 inches unless otherwise indicated. In partially grouted masonry, provide fully grouted units under the full lintel bearing length, unless otherwise indicated. Composite walls. Tie masonry together with joint reinforcement or with unit wall ties. Embed wall ties at least 1.5 inch into mortar of solid units and at least 1/2 inch into the mortar of the outer face shell of hollow units. Space ties at a maximum of 16 inches horizontally and vertically, as indicated in drawings. Insulation. Insulate cavity walls, multi with non-composite masonry walls, where shown, by installing board-type insulation on the cavity side of the inner width. Apply board-type insulation directly to the masonry or through wall flashing with adhesive. Neatly fit insulation between obstructions without impaling insulation on ties or anchors. Apply insulation in parallel courses with vertical joints breaking midway over the course below and in moderate contact with adjoining units without forcing. Cut to fit neatly against adjoining surfaces. Tape or seal the joints between the boards. Insulation will act as air barrier surface and all joints and gaps shall be sealed. Built-in items. Fill spaces around built-in items with mortar. Point openings around flush mount electrical outlet boxes in wet locations with mortar. Embed anchors, ties, wall plugs, accessories, flashing, pipe sleeves and other items required to be built in as the masonry work progresses. Fully embed anchors, ties and joint reinforcement in mortar. Fill cells receiving anchor bolts and cells of the first course below bearing plates with grout, unless otherwise indicated. Closeout take-back program. Collect information from manufacturer for take-back program options. Set aside masonry units, full and partial scrap packaging to be returned to manufacturer for recycling into new product. When such a service is not available, seek local recyclers to reclaim the materials. Submit documentation that includes contact information, summary of procedures, and the limitations and conditions applicable to the project. Indicate manufacturer's commitment to reclaim materials for recycling and/or reuse. Protection. Protect facing materials against staining. Cover top of walls with non-staining waterproof covering or membrane to protect from moisture intrusion when work is not in progress. Continue covering the top of the unfinished walls until the wall is waterproofed with a complete roof or parapet system. Extend covering a minimum of 2 feet down on each side of the wall and hold securely in place. Before starting or resuming work, clean top surface of masonry in place of loose mortar and foreign material. Now let's review typical CMU details on structural drawings. It can be found on the first structural drawings with the letter S, typically S101, S001, or S002. Masonry notes that describe CMU characteristics such as compressive design strength of CMU and grout. Grout pour height requirements. Also, you can see the reinforcement anchor specifications, lintel blocks requirements, reinforcing steel grade. Bar clearance detail, lap splices requirements. In this drawing, you can find masonry veneer anchors installation requirements. This sheet shall be reviewed together with the project masonry specifications section when performing an inspection or if you're contracting officer representative. Next, let's take a look on details on drawing S506. Detail 2 depicts CMU vertical and horizontal reinforcing, wall elevation, bond beam location. Horizontal rebar spacing shall be 48 inches maximum. Dowels and foundation shall be straight bars embedded with 1 lap length into concrete foundation at contractor's option, as per Note 3. Always read notes, there's a lot of information that helps during placement and inspection. Also, reinforcement detail through masonry control joint. Bond beam rebar shall be terminated at each side of the control joint. In the attached pictures, you can see the control joint with terminated horizontal bars with a 180-degree hook. Vertical reinforcement that is spaced 16 inches on center. Horizontal reinforcement that shall be spaced 48 inches on center. CMU foundation dowels. Dowels lap splice. bond beam reinforcement at the top of the wall with 2 number 5 rebar. Additional bar at openings. Let's move to detail 1. Typical reinforcement at CMU wall. 8-inch CMU wall shall have single-layer vertical reinforcement. 12-inch CMU wall shall have double-layer vertical reinforcement. Single or double layer shall receive 2 rebar at corner, 2 rebar at ends, and 2 in intersection. All horizontal reinforcement shall end in a 90-degree or 180-degree hook, which shall wrap around main vertical bar. In the attached pictures, you can see 12-inch CMU wall with double vertical and horizontal rebar. 2 reinforcements at intersection and 2 at the end of the 8-inch wall. 180-degree hook wrap around main vertical bar. Let's continue to review detail 1. We can find typical reinforcement, standard 90-degree hook. Intersection details. Lap splice. Reinforcement at corners. Now, let's review detail 3, where we can find CMU reinforcing schedule table. The table shows vertical and horizontal reinforcement schedules for 8-inch, 10 and 12-inch walls. Rebar location detail for masonry control joints, bond beams, and lintels. For instance, in an 8-inch wall, the vertical bar will be 1 number 5 at 16 inches. In 12-inch wall, bond beam will be with 2 number 6 rebars. In the notes, we can see grouting requirements. All CMU cells must be grouted. 2 vertical reinforcements shall be located at all corners and each side of all masonry control joints, as per note 3. Provide wire rebar positioners to hold bars in place. Stop grout pour half an inch below top of course at each grout lift. In the attached pictures, you can see full grouted masonry wall cells with half an inch clearance at the top of the course to create a shear key for the next grout lift. Wire rebar positioner. Let's move on to detail 4. Masonry reinforcing splice table. Masonry lap splice depends on bar size and wall thickness. For instance, for 8-inch CMU wall, lap splice for number 5 rebar would be 2 foot and 7 inches. For 12-inch CMU wall, lap splice for number 6 bar would be 4 foot and 4 inches. In the attached picture, you can see the foundation dowel lap splice for number 5 vertical CMU reinforcement. Next, detail 8 depicts lintel support. Lintel shall be steel angle size as shown on drawings, lintel attached and secured to CMU wall with 3/4 inch diameter anchor bolt with minimum 5-inch embed at 16 inches on center. In the attached picture, you can see a lintel secured above the door opening. Veneer shall be placed above the lintel on 3/8 inch mortar joint with continuous joint reinforcement. Let's review the next detail with typical masonry control joint that's shown on detail 6. Control joints are used in CMU walls to minimize random cracking. Condition shown for 1 and 2 layers of reinforcement. Horizontal reinforcement shall terminate through the joint except as shown in CMU elevation. Preformed gasket is typically used to prevent air movement between rooms. Joint spacing shall be 24 feet. We will review plan details for joint location and spacing in our next drawing. Similar condition for control joint and wall corners. In the attached picture, you can see a control joint with installed gasket, terminated horizontal reinforcement and additional bar at end of the wall. Let's review detail 7 where we can find anchor bolt and masonry. An anchor bolt is used to attach steel angle which will support metal deck with concrete or holding CMU wall with structural steel. We will review a couple of details in this video. Anchor shall be installed with 4.5 inches embedded into CMU wall with minimum 1 inch clearance to block wall. In the attached pictures, you can see anchor installed above bond beam and before grout placement. Final CMU rebar inspection is required before grouting. The next picture shows anchors after the grout placed and consolidated and the forms have been removed and are ready for angle installation. The next step is to install a supporting angle and metal deck. Metal deck installation and inspection will be reviewed in a separate video lesson. Detail number 1 shows typical deck support with steel angle attached with embedded 3/4 anchor, spaced 1 foot and 4 inches in CMU wall. 2 number 5 bars are required at the top of the wall with 90-degree bent dowels into the slab and welded wire reinforcement. The attached picture shows metal deck reinforcement as per detail number 1 requirements. Let's move on to detail 5, where we can find lintel installation requirements. In some cases, a lintel may not be needed if the opening is less than 8 inches wide. Please review note 1. Lintel shall be provided per the table above, which describes lintel size, length, reinforcement quantity, and size. Typically, all lintels types shown on the drawings, if not lintel shall be provided from the above schedule based on the thickness of the wall and maximum clear opening size. If none of the above is shown on drawings, verify lintel type with engineer prior to construction. In the attached picture you can see section of lintel at opening with stirrups with 180 degrees hook and adequate reinforcement clearance. Typical lintel reinforcement is 2 number 5 or 2 number 6. Next, we will review detail 6, CMU connection to the floor or roof. Bent plate with 2-inch long slotted hole, with 3/4 inch anchor bolt spaced 1 foot 4 inches, with 5.5 inches embedment into the wall. Bolt shall be hand tight at the time of installation. Detail XX shows the front view of the depicted detail on the left. In the attached picture you can see the required slotted hole, vertical reinforcement, and ongoing CMU wall placement. Detail 10, typical CMU wall supporting metal deck. 3/8 inch continuous plate by 4.5 inches wide, with 3/4 diameter welded studs, 4.5 inch long, spaced 1 foot 4 inches on center top and bottom. After the wall has been erected and inspected and grout placed, but before grout solidified, the plate will be placed facing studs down, the top stud to be welded after metal deck installation. Let's take a look at the sheet, S107, where we can find a plan view with wall types, section details, cut-through walls, masonry control joint location. In the general notes section you can see, concrete, CMU wall denotes. Moving up with the drawing we can see concrete and CMU walls. You can find wall dimensions, door sizes, CMU wall connection to column, concrete wall detail to CMU wall. From the top of the drawing, we can see the grid line of the building section, which helps to navigate when performing placement or inspection on the job site. You can find masonry control joint quantity, location, and size of it. Moving forward, let's review detail 7 on drawing 05S508. This detail shows grouted CMU wall to structural steel column, column with 3/4 inches welded studs, horizontal and vertical reinforcement details, CMU wall ties, wall's location, size, and dimensions. Also you can find 4 inches seismic joint. In the attached picture you can see the wall erection is in progress, with ties and horizontal reinforcement not placed yet. Let's go back to the plan view and look into the cut through the wall detail. Let's take a look at the full building cut market section A on sheet S315. Here we can find wall elevation, wall size, wall details, seismic joint characteristics. For more details on CMU wall connection to structural steel, let's review detail 8 on S509, where we can see 3/4 anchor bolt installed 2 feet on center with 6-inch embedments. The bent plate must be spaced 5 inches max from CMU wall. An additional number 5 bar shall be installed above the anchor. In the attached picture, you can find this detail after CMU wall erection. Let's review another cut wall section along grid line H. Detail 3 on sheet S510. This detail shows a metal deck supported by a steel beam. Steel beam attached with bolts to the plates embedded into CMU wall with welded studs. In the attached pictures, you can see the embedded plate before installing it into CMU wall with 4 welded studs. The next picture shows the plate after being installed and grouted into CMU wall with welded knife plate to secure beam with TC bolts. Last picture depicts beams in place, the metal deck placed above the beams, anchors and angles attached to CMU wall to support the metal deck. During construction and walls placement, it is a very common mistake to find missing embedded plate. In this case, the contractor must send RFI to engineers to provide detail for plate installation. Below is the RFI sample that was created by contractor with missing embedded plate and steel beams for stair. At the same time, contractor proposing to accept fixed solution, in a way to drill and epoxy new structural steel attachment members to the north, east and west faces of the concrete column. If the proposed drill and epoxy solution is not acceptable, engineer to provide a structurally acceptable solution. The following response instructions was provided by the structural engineer. Contractor shall be carried out in accordance with the contract documents without change in the contract price or contract time. Otherwise, request a construction change order immediately. The engineer provided detail for post-installed attachment for stair to drill an epoxy threaded rod with 6-inch depth, and place missing plate above the concrete column. In the attached picture you can see the plate installed above the concrete. Furthermore, before drilling the wall, contractor to locate reinforcement steel with X-ray scanning. It is very crucial to not damage rebar during drilling. Now, let's take a look at the architectural drawings. The difference between architectural and structural drawings is the structure is an essential element that defines the architectural shape and space. The structure contributes to the aesthetic value of the building. The structural system is not exposed but still has a significant influence on the form of the building. There's typical conflict between architectural and structural plans. Upon checking the plan, you notice that the size of one column is different in the architectural plan and in the structural plan. For structure, the structural drawings and notes always override anything on the architectural drawings. For many building types, the architect isn't allowed to do the structural design or calculations. An architect is not a licensed structural engineer. Architects can do structural design in some cases, but this varies by state licensing requirements. Our experience has been primarily with commercial, institutional projects where always have a structural engineer consultant. The conflict has to be resolved, but in most cases, it will be the architectural plan that is adjusted. Here, we have an architectural building plan view drawing where we can see all wall types, windows location, door sizes, room names, and required dimensions. Also, you can see corner detail, cut-through building detail, and building side view. Let's review each detail individually. In detail 2, on drawings 5A201, we can see the building from the north side with the given building components. Top of CMU wall dimensions, windows, doors identifications number, control joint location, roof and wall types. Remember, architects do not add the structural details on plans. Typically, they have partnerships with structural engineers who add detailing to the plans for you. If this is the case, the architect may include structural engineering costs in their overall quote. Let's go back to the plan view and look at cut-through building detail 4, on sheet A311. Here, we have wall side view with CMU wall details and dimensions, which is very important for subcontractors to make their shop drawings and for contractors when performing wall placement and inspection. Moreover, architectural drawing is always drawing with a purpose, an instrument rather than an end in itself. Even a highly polished perspectival view, for example, is a tool for showing a building as it might appear when built, rather than a finished work in itself. Next, let's go back to plan view and look at corner detail 4, on a 510. On the plan detail, we can see CMU wall attached to the concrete wall that is finished with masonry veneer and tie spacing. Overall, you can see the design idea to assist a building contractor to construct it based on design intent. A simple but common mistake is drawings not being complete. This can be a particular problem where designers do not have the necessary experience, supervision, quality systems, or time to produce the drawings required. Incomplete drawings can lead to requests for information and change orders when the work starts on site. Let's return to our plan view and look at wall types shown on the plan under letters A through D. In this sheet, you can find wall type, whether it is CMU, concrete, or metal stud wall. Also, the wall thickness, height, fire rating, and wall sheathing requirements. Internal walls typically fall into two categories: load-bearing walls, sometimes referred to as structural or solid walls, and partition walls. Load-bearing walls are constructed from mortar-bonded masonry in the form of fired clay bricks or concrete blocks. Partition walls can be solid, typically constructed from brick or blockwork, or can be a framed construction. Framed partition walls are sometimes referred to as stud walls, and can be constructed from a timber, steel, or aluminum frames clad with boarding such as plasterboard, timber, metal, or fiberboard. Thank you for taking the time. If you enjoyed this video, subscribe to the channel and leave a comment. Building Code Academy wishes you all the best on your road to becoming a certified professional. Bye.